Okay, thanks for introducing me. All right, I'm excited to talk about mecosystem, which is an embedded system for aquaponics. So what is aquaponics? So you can see over here this large prototype. And so aquaponics is a combination of fish and plants in a symbiotic ecosystem. We also have bacteria that plays the roles of actually getting the food for the plants. And this process uses 90% less water than traditional agriculture, making it sustainable for the future. So off the bat, I'd like to acknowledge some people that have helped. My partner, Neil Griffin, who's an architect student, helped design all of these mecosystem prototypes that you'll see in the slides today. He also helped with all the plumbing and everything and was the primary lead on all that. I'd also like to thank my professors that helped with this. And the tools I used was Arduino, Flask, and Fritzing. And I made extensive use of the Idea Shop over the course of this project. So how does it work? So here are some of the components listed. We have grow lights, we have fans, we have bell siphons that drain the water, we have a pump that pumps the water up to the plants, and the plant beds where the plants actually grow. So some previous work. I started out about 6 months ago with an aquarium in my apartment, and I put a box on top, put a pump inside, and started pumping up water. And I started to see how can we grow plants out of the aquarium. I started with an embedded system which uses a Raspberry Pi, and it didn't work very well. So I learned from all these mistakes, and that helped me create the one that you see here before you today. And the prototype on the far end of the screen is the same one without the front cover on it. So what kind of stuff can we grow in this system? We've been able to grow wheatgrass, I've grown lettuce, cilantro, kale, and a lot of other things. And I'm constantly experimenting with other things that we can grow. And so what makes this happen? Well, I use this board called an Arduino Yun. And the big difference between this Arduino and the ones you've heard about earlier is that there are two processors on this board. It's a little bit more costly, but it makes it well worth it by the functionality it gains. So the typical Arduino is the same stats as the one you see up here. And there's a bridge in this diagram on the right that shows how they connect to the Linux microprocessor. The Linux microprocessor is substantially faster than the Arduino at 400 megahertz and has about 16 megabytes of RAM opposed to the kilobytes. So it is substantially larger, but it is very small for a Linux system. One of the other main benefits of that is you can upload your code wirelessly. You don't have to plug it in every time to run a firmware update or something like that. And as you can see up here in this diagram, there's a lot of wiring going on. But there's 6 relays, 3 temperature sensors, 2 humidity sensors, and a pH sensor to measure the aquarium. This is how we determine where everything gets plugged in. In the beginning of the Arduino file, there's a typical association of pins to Arduino, to sensors. And so the sensors that I'm using are the humidity sensors to determine the humidity of the different areas of the system. It's the DHT22 model that we've used in class this semester. And I'm also using an analog pH meter made by DF Robot, which measures the pH of the water and makes sure that the aquarium is functioning how it should be and that life is sustainable. And lastly, these one-wire sensors are waterproof temperature sensors. They're able to monitor the temperature of the water and of the plant beds. So this sensor demo right here shows kind of the real-time data collection. It also prints this information to the serial port of the microprocessor as well as to the cloud using that Linux processor on board. So you can see it'll cycle through. So here's the pH. It says 0 because it's out of water right now. The temperature in degrees Fahrenheit of the third sensor is 62. That's the pH sensor again. The humidity sensor is about 25 and 26 on each sensor. So you can see it cycles through this infinitely. Okay, so how do these relays work? These relays, there's about 6 of them, and they control the different aspects of the system, ranging from the lights, the pump, to the fans, and there's also one for adding additional functionality of whatever you want. They also control the temperature through the temperature sensor earlier. All right, now we're getting to the code. We're getting to the good stuff. The scheduler here, it runs at 1 hertz. That means 1 time per second. This counts time in a software clock. Basically, it'll count seconds, minutes, and hours. And so every 1 minute, it will tell the scheduler, hey, check if anything needs to be turned on, check if our pump needs to run or our lights need to change. And this inspiration came from the Linux cron table, and kind of mimic that in this code up here. So we have the configuration file at the top. You tell what times you want your lights to turn on, how often you want to pump the water up to the plants and have it drain. And the timer will tell the scheduler every minute, hey, check if anything needs to turn on or off. The scheduler will do that and change the states of the relays. It also collects data from the sensors, pushes it real time to the 7x4 character display in the video earlier, as well as pushing it to the Linux side and maintaining a database of all the sensor values for data aggregation at a later time. So now, what does this product cost? Well, at sales price, it's about $2,000. There's over 100 components inside, and this would include things like the fish tank, the lights, the pumps, all of the kind of components you see in front of you here today. The electronics specifically at cost are range about $200 to $250 because that Arduino unit's a little bit expensive and all of those sensors and outlets. So in the future, to move forward with mecosystem, I would want to develop a library because right now there's a lot of code there and there's a lot of functionality that's kind of obscured through it for users to actually implement. Another big part of it is the server. This Linux processor allows for distributed Internet of Things server on board the system, and that can be really dynamic and have a lot of functionality for viewing your statistics over time and determining whether something needs an update, as well as creating an Arduino shield, which will actually plug into the Arduino and make the whole embedded systems actually function a lot more smoothly. So if you'd like to learn more about mecosystem, you can view the code on GitHub, as well as sign up for our newsletter at mecosystemlabs.com. And please like our Facebook page, facebook.com/mecosystemlabs. And these are some of the references I use, some aquaponics forums, some competition. Kajani Grows is an embedded system developer, and a lot of Google searches. And so in conclusion, your food is traveling thousands of miles to reach you. Your lettuce comes all the way from California, and that's just so far. Maybe we can bring this process closer to you. And the solution here is an autonomous aquaponics system. And so thank you very much.